Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
So I'm Martin Thwaites. I'm a developer advocate for Honeycomb. I've been doing .NET for the past 2 decades, since the start of .NET, and I'm here with Hannes to talk about the evolution over the last 2 decades. Can you tell us a bit about yourself?
Yeah, I'm Hannes. I work as the head of learning and development for a company called Axxes in Belgium. I've been doing .NET ever since 2.0. I've done 1.1 when I was in college, so I've experienced pretty much all of the evolution of the ecosystem throughout my professional career. And that brought us to a talk that we wanted to have about how we experienced that journey, right? It's more about that than about the factual parts of everything.
Yeah, so, starting back then and sort of as a college or school student doing .NET 1.1, do you see a lot of what you were doing back then in what you're doing now when we're in the sort of .NET Core and now the new .NET world?
Well, a lot of the stuff that we did back then, it still works. I mean, you can still do similar things with .NET, except you can also do a million things that you couldn't do back then. For me, like the first reality check was when they broke all compatibility going from 1.1 to 2.0, because 1.1 is what we had in college, and then I arrived at my first proper job and they were doing, oh no, don't do 1.1, like that was the broken version. They fixed a lot of it, so switch to 2.0. Here, install Visual Studio 2002 or 2003 it was that introduced 2.0. Like install that and work with that. And then I tried my code to compile, but of course all the namespaces were broken and a lot of the classes didn't exist anymore. And it's like, okay, we're gonna start over. That was my first reality check with .NET. It's like how I entered the work field.
Yeah, I mean, I was very similar. I remember the big green box of Visual Studio that I got, and I'm completely self-taught at that point. That was my entry point. So
at that point, they were still shipping all the documentations with the box. You would get it on, like Stack Overflow wasn't a thing. It's like you got the MSDN documentation on DVDs when you got your Visual Studio box, and you could opt to use it from the DVD, or if you had lots of disk space and a powerful machine, you could install it to disk and get faster access to the docs, right?
Yeah, that was a bit of a revelation when they did MSDN Online, for instance, when you could actually just search it. That was that first experience of being able to install stuff off the internet.
And you still see Microsoft's documentation efforts haven't really changed much. I mean, the documentation that they now have online, MSDN on the DVD, that doesn't exist anymore. But they do keep their docs pretty much up to date with code samples and how to use things. And you technically would not need Stack Overflow to find a certain feature of the language design and so on. You can find that in the Microsoft docs, and you'll have it in all the different versions of all the different frameworks if you want to.
Yeah, I think that's been a big push that they've made to lower that barrier to entry, because previously it was a very disparate bit of information that you would have to find. You'd have to go onto the MSDN docs. And I think they've made a massive push to build the docs.microsoft.com as a site that is a go-to place for people onboarding. How do you feel that the onboarding experience has moved from when you were way back installing things from a CD through to sort of where we are now in that evolution?
Oh, a lot of things happened in that period. Like in the beginning, we were installing everything. And then what I remember, like the way that you kept up to speed with things. You had a Visual Studio release, that meant a .NET Framework release, and all the features that were in there. You would get security fixes, but you basically had time until the next Visual Studio to learn all the new stuff, right? So that you were up to speed. I think they started decoupling that around 2010 with .NET 4. Is when they pulled out the release cycles of a couple of .NET products. For instance, the MVC stack and the Entity Framework stack, they were moved onto their own release cycles and were not paired to Visual Studio anymore. So suddenly you were learning things all the time, and that has changed tremendously. Also, one of the things that stood out to me is like the pick and choose installer. In the beginning, like installing Visual Studio was something that was complex, and you had to know what you were going to do after you installed it, even when you were running the installer, because you had to pick which stuff that you wanted to be installed with it. And now they I think it was it 2012 or no, it was 2017 where they revamped the whole installer, where you could basically pick certain workflows, and it would suggest like, okay, if you're going to do desktop development with Xamarin, you're going to need these parts of Visual Studio, right? Yeah. All that kind of stuff became a lot easier. And now that we're moving, because there was this tendency of moving from smaller applications to bigger and bigger and bigger applications, and now that we're all switching back to interconnected collections of smaller applications again, you can see that the .NET ecosystem is also lowering the bar of entry to build those. If you scaffold like right now with .NET 6, if you scaffold an MVC application, you're not going to get controllers anymore. Like that bar of entry is a lot lower than it used to be. And I think that if we look at the ecosystem of a lot of programming languages, that is a really good thing, because we're making it a lot easier for newcomers to get into .NET. Because we took all that stuff for granted. We've been there for the evolution. We've seen web forms, and then web forms was a wonderful attempt from Microsoft to transfer the skills that people had building desktop applications to the web, right? It was just meant for that. It meant horrible things like view state and all the things that came with that made our life hell, and it made it pretty much impossible to performance tune. But it did do that for the .NET ecosystem to bring all these line of business desktop developers into the space of the internet.
So what I would challenge that a little bit, that view state was a thing that with great power. It's yes. a thing that was useful. It can be abused, and that is the big problem, is that what we did at the point when we had web forms was we made it easy to do the bad thing. We made it easy for you to take your customer object and serialize it into view state and have a 40 megabyte view state in your page. We made it easy for people to do. We didn't make it obvious. And
exactly. That's the biggest problem. We didn't make it obvious what you were doing. And that's why a lot of people fell into that trap. It's not because they consciously abused the system. It's just that the system pushed the wrong attitude onto the developers, right? Which is why a lot of people hated web forms.
Yeah.
And when the MVC came along, which was a mirror of what in a lot of other web-first programming languages was happening at the time, that made a lot of sense. Having this a lot cleaner server-side rendered HTML, but not necessarily thinking of like we're going to do the same page over and over again and we have to transform the page loads and take data with us between them. You put that into the hands of the users. Like, you want to post something back to this controller, you're going to be making sure that it is actually in the form data that is pushed onto that controller action, right?
Yeah. I think web forms was trying to be so many things to so many people.
Yes.
It was trying to be that Swiss Army knife that allowed you to do absolutely everything. And at the time where it came out, absolutely that was what people needed. As you started to move on, and you mentioned 2017, and when we started to move towards this idea that people who develop for desktop are not the same people who's developed for web, and that separation of that workflow within the Visual Studio stuff was a bit of a revelation, really, where we started to understand that actually web development is very, very different to WinForms development, to building things for desktop, to building things for mobile. We tried to stop being one size fits all for all these things. And I think that was that moment where we started to think a lot about web performance and around this idea that using web forms was great when you're doing line of business applications, and you can write other applications in it. But when we start to think about pure web development, where you are using a browser, we started to have that the 2G, 3G, 4G, 5G sort of evolution of mobile, where actually getting the page load times down was really important. Really important.
It really
Thinking
was.
about controls, being purposeful about what you send back and forward over the wire, making developers really think about what's important to them. And have you seen that in the things that you've been doing recently, where you've been working with .NET Core? Do you think that you think about the development a lot different now than just have everything?
Like a lot of things have changed there as well. For instance, like dependency injection was an afterthought for a long time. And in .NET Core, they made that a first-class citizen in the ecosystem, which brought a lot of the patterns and practices that people had been doing, also in .NET for a long time. They brought it to the masses. Because the file start new project template for a long time, if you did an MVC application, was let's just have everything in one assembly. And it's really good for demo purposes, but if you want to build anything that a team is working on, you might want to maybe separate your code a little bit and make sure that you have clean dependencies so that you can get some of your logic tested, right? That was not something they had in mind when they were doing these application templates. And I feel that they're cleaning up a lot of those things to reflect what the community is doing with .NET is being reflected back into the framework. And they're also being pushed from the outside. It used to be this Windows-only, you had Mono, but it used to be this Windows-only framework built and run by Microsoft. Whereas in .NET Core, we see it runs cross-platform on everything by default. We are having, for the first time in 2 decades, we're seeing a third-party IDE to develop .NET. JetBrains released Rider. You can write it in Visual Studio Code as well. You can basically write .NET in everything now and run the compiler tools with it. So that is changing tremendously, and it is all coming from what are people doing with .NET out there. How can we bring that back into the whole system? Cloud was a thing, so they needed to move cross-platform. Like the templates that incorporated solid and dependency injection and so on, that was a thing, so they are the default now. All those things are changing. What we're also seeing is there are so many ecosystems out there that have a very, very low bar of entry. Look at Node, like writing an API that responds to a request is only a couple of lines of code, where in .NET it used to be controllers and actions and whatever. It's like
CS
a whole
proj files.
Yes, like a whole
package JSONs,
a whole bunch of files and dependencies and so on to do like that one thing. It's like we're going to respond to a request, and the fact that they have looked at that and reflected, it's like, okay, how can we keep all of the power that we have in the ASP.NET framework, but lower the bar of entry so that if you want to prototype something real quick, or if you want to build something that isn't as complex as these huge enterprise services that we both probably have seen in our careers, but like a simple API that does a couple of things, you're going to have something that has very little code. And this has always, in my opinion, because I've been there for the journey, I've seen it all, for me, it never felt like we were doing too much work. because you have these classes in your fingers. It's really quick to make it. But for a newcomer, it feels like, oh, I need to like understand all these things because all the code is there, right? It's all C# files. So if you've never seen .NET before and you do the new project for a web project, you can see all the files and you wonder like, what does this bit do? What does this bit do? And basically all of it is like default configuration for
boilerplate.
Yeah, it's like boilerplate to be able to answer an HTTP request, and now you just get like a single file of code and it just does just that. Yeah. And all the stuff is still there. It's still there behind the scenes and it's accessible if you want to do it. You just don't have to anymore.
So the minimal APIs is a really interesting thing because you and I both saw the Twitter blow up when they started sharing the minimal APIs, the traditional 20-year .NET developers looking at this going, I don't like it, it's wrong, this isn't .NET. And I was one of them. I looked at this code and I was like, this isn't the .NET I know. And it took me quite a while to get around to that idea.
But isn't it good that it isn't the .NET you know?
And that was the point. That knee-jerk reaction that this isn't the .NET I know. But .NET needs to evolve. .NET needs to become more things. Now, what we didn't do is we didn't remove all of the stuff that already existed. You can still do things
you
the way
you mean
that
like
you want.
the 2.0 to 4.8 journey of which was a decade and a half of building stuff on top of.
Yeah.
And the language specification basically didn't change. You had 3 different runtimes. Like there's everything pre-4 and then there's 4 and there's everything 4.5 and up. But the language, they didn't remove anything. So all of the stuff that was there when I did 2.0, like the first years of my career, I can still do that in a supported version of .NET Framework today, and all that code will still compile and run on the latest. I mean,
you wouldn't do that obviously because
there would be no point.
Nobody hates themselves that much, obviously.
No, and I mean the type of applications that we were writing was so different from what we're doing today. That there would be no point to cross-compile anything from back then because those tools have long been replaced. I mean, I wasn't that good that anything survived through the ages that would still be running today. But theoretically, you could. But the fact there is no point. And the big re-engineering came when they started thinking about we need this cross-platform runtime. It's like, okay, we have an opportunity to start over. Which bits of this old thing that we have here were good and do we want to bring over? Which bits could be improved and we're going to actually break compatibility there. And then you get into this whole limbo of .NET Framework, .NET Standard, .NET Core, and then you now have .NET 5 and 6, which were actually .NET Core 4 and 5, but for reasons they called them .NET 5 and 6.
We can't call it 4 because 4 exists. So
yeah, 4 exists, but it was Framework 4 and not Core, and they wanted to get rid of the Core thing. And see, this is the look that I get from people when they ask me, like, what is this .NET Standard thing? And then you have to bring them this whole explanation. It's like, okay, they had some bits that they wanted to bring over from Framework to Core. They wanted to have libraries that you could cross-compile to be used in both sides of the .NET ecosystem, which was very important for all the package makers and component vendors and so on, so that they can build a single code base but run them on both sides of the... Yeah.
And you didn't have to cross-compile across multiple frameworks and have if-defs everywhere to, if I'm running on full framework, then I need this.
But if so you didn't need that. So it was a good solution to the problem, but if you weren't there for that to happen, understanding how like Framework and Core and 5 and 6 and Standard, how it all works together, because now you have .NET Standard 2.1, which is not compatible with full Framework anymore.
Yeah, but we should just be going to .NET 6 and then 7, then 8, then 8, then 9, then 10, then 11, and then Vista, and then ME, and obviously the way that things are going to go.
The thing is, like .NET Standard, which was like the way that you could write libraries that you could use in Framework and Core and Xamarin runtimes, has now like ditched the whole Framework compatibility in the latest versions. So even if you were used to the fact that like, okay, I can make a standard assembly and have that on 2 sides, that's no longer true.
Yeah. Let's be honest. Versioning from 1.1 through to .NET 6 of where we are, and everything in between has been a dumpster fire. Now, there were multiple opportunities that we could have done it better, but we didn't, and that's the past. I think what we need to do going forward is just look at, when we're talking to people about it, we talk about .NET 6, and it's just .NET 6. That's all it exists.
Yes.
Forget about everything that came before.
I think that's why they did the naming switch. That's why they dropped the core. It's like, we want you to talk about this. And 5 is higher than 4.8, so you're going to be talking about .NET 5 and .NET 6, and we're going to forget about the old stuff. But we'll be seeing like framework stuff in production for the next decade to come. Yeah. I'm pretty sure.
So my biggest problem with the idea of moving back to .NET as the name of the thing that we're building against is hiring .NET developers.
Yes. Because
I've always seen a difference between a .NET Core developer and a .NET developer. Now, we've seen the evolution, and we talked about the evolution from a web forms focused approach through to a .NET Core, controllers, MVC type approach, where we've got extensibility, we've got dependency injection as standard.
Yes. Everything is sort of built in, and we don't have to rebuild things. Well, we got extensibility quite early on. It's just not a lot of people liked it.
Yeah.
If you think back to like .NET 3.0 WCF, that was like the most massively over-engineered and extensible part of the framework that they ever built. And everybody hated it because it was complex and extensible. And
I love WCF.
I did a lot of awesome things with it, and once you
did a lot of bad things with it.
Yeah. Like duplex bindings, I should never have used those. I mean, there's better solutions to that problem. But the thing is, it was a very, very, very powerful tool, and it lived on in its original state for quite long because it was so extensible.
Which brings us nicely onto backwards compatibility, because recently Core WCF was released, which is a .NET Core version of WCF. And this is because we have so many people who are wedded to these technologies. They're wedded to SOAP. They're wedded to this old school idea of how these APIs work. Because like you said, we're going to be dealing with full framework stuff for the next decade at least.
Which is why they did the... Originally, they were only going to bring over the client side of WCF, right? We want our new services to be able to call the old stuff, but we don't want to build services this way anymore, right? That was the first philosophy.
Yeah.
And then there was like a whole part of the industry that revolted against that because they had built their own microservices frameworks on top of WCF. I wouldn't today. Is that if I would have to do cross-process communication in a remote procedure call way, the way that WCF was built, there's way better options, for instance, in gRPC, which is way faster, it's a lot easier to set up, a lot less things that can go wrong. I don't know if you know this, you probably do, because you know Mark as well, right? Mark Randall, he built like this whole conversion product that can take old full framework WCF code and generate working .NET standard assemblies that have gRPC services in them, and they don't break compatibility. So you can basically remove your WCF services from your product, replace them with gRPC, gain a lot of performance in the process, because you're doing away with all the XML and all the SOAP stuff.
So a fun side quest on that one. When Mark was building that thing, he asked for people to provide him with examples of WCF.
Yes.
I showed him the example of my very bad things in WCF and managed to crash his solution multiple times because it was so easy to do the bad thing in WCF. And there were so many people who were, like you say, adding extensions. They were doing things that weren't the things that you would imagine them doing. And then you try and then say, let's create a gRPC version. This is why converters don't always work. Let's take that thing that was written in a, the hello world example of WCF, convert that into gRPC, great, everything works. Take the 20 years developed WCF solution that somebody's got over here and try and run that through a converter and try and make that into gRPC. It's a really, really hard thing, which is why that tool exists, because it's really hard to do. But it comes back to what I was saying about what we did in the past was make the bad thing really easy to do. And I think what we've done a lot of within the .NET Core world, and now
is make it easier to do the right thing.
Yes, make the right thing the easy thing to do, and then people just go down that route. And I think we are starting to get to this point now where we're training that out of people. We're training it out of people to say, go and use, you want a logging framework? Well, don't write a logging framework. You've got iLogger. Just use iLogger.
Yes, and then plug whatever logging framework into that.
It's one of my favorite things about .NET Core is this killing of that debate.
Yeah.
And one of the talks I give, the thing I say is when you used to start a project back in 4.8 days.
Yes.
The first 6 to 8 weeks of the project was deciding which logging framework you're using.
Yeah, like logging framework, which DI container are we going to use, like all that. Which ORM. I mean,
and now you don't need to. Now what you start doing is saying, I'm just going to use iLogger. I'm just going to use the out-of-the-box dependency injection. I'm going to use the out-of-the-box observability solution. All of that kind of stuff is just out of the box. And then
logging
later
also
down the
changed
line,
tremendously. I mean, when we were back in the days, it's like writing stuff to a file on the server that your application was running on, right? So you had to give your IIS service user write access to a folder on disk so that it could dump its logs somewhere.
But then you put it on a network share because then you had a server farm.
Okay,
and then you have a network share between all of them.
Yeah. Well, we've all done those things, right? But now we are. I think a lot of the new code that is being written is deployed in a containerized way. Whether you run it on Kubernetes or not is irrelevant. But if you're going to push it into the cloud somewhere, chances are pretty high that you're first going to build it into a Docker container and then run that.
Either you run it in a Docker container or somebody else runs it in a Docker container.
Because there's these frameworks out there and these orchestration platforms that just let you upload a zip with your code, but what they do is indeed convert it to...
I mean, just take app service in Azure.
Yeah.
The Linux-based stuff is all built in containers now.
Exactly.
So you are running it in a container. You might not be running it yourself, but you are running it in a container.
You can just upload a container to an app service as well. So that works perfectly. But what we do there is we have changed from this idea our logs need to be in a file to the idea of we need to put our logs out there somewhere. And you can either in containers log to standard out and then gather logs from there, which is, if you want to do the standard way of logging, would be the way to do it with containers.
12-factor app methodology. Write to out, get somebody else
write
to do
to out, and then parse that, right? But what we've also been seeing, and this was something that was pretty big outside the .NET ecosystem before it came into it, you had these vendors New Relic, for instance, that were looking at okay, we have these logs in these distributed applications, and there's so many things that we want to know, right? We don't only want to know what the developer thought that he had to write to logs. We also want to look at how long do these things take, which database queries are being executed in the backend and take a long time. What is the load on the machine that this is running on, and correlate all that data into something that you can actually use to troubleshoot, because reading logs is hard. We've all done it. If they give you that plain text file, finding out what's going on is a lot harder if you don't have context. If you add context to things, it becomes a lot easier to process. And you can actually figure out what's going on with your system.
So you're about to open the door into a rant that I will probably spend the next 4 hours on.
I don't think we have 4 hours.
So what you're talking about there, the idea that we are starting to now, in the .NET world, think more about our production systems.
Yes.
We're really starting to think now about it might work locally. It might work on our Visual Studio instance when we hit debug. But we now need to start thinking, because we're running it in containers, we're running it in the cloud, we're running it in server farms, we're running it not on our machine, we're running it at load, at scale. Those are things that we really now need to start thinking about observability of our platform. We need to start thinking about how do we get that information out of that platform, where logging, it doesn't work on a file system anymore.
No, it doesn't. It doesn't get us where we need to be. We know why we want the logging. We want to figure out what's wrong. But logging is maybe not the tool that we needed to solve that problem. And I think credit where credit is due. I think a lot of the awareness in the .NET ecosystem came from Microsoft including application insights into the default application template. So that developers were pushed to go and take a look. They were at least triggered to go and take a look, like, what is this all about? Why is this here? What can a platform like this do for us? And in the early days, application insights didn't do a lot of things, but it offered you some out-of-the-box visibility on what your code was doing in production, even without properly writing any. Because that was the thing with logging. If you want to write something to the file, it's a conscious decision. Whereas like metrics and performance numbers and all that sort of stuff, you're not writing that out by default, but it's very interesting for you to know. So you want to have more information than that, but you don't want to spend all the extra work of instrumenting all your code with all those log statements, right?
Yeah. I think
that's where these tools come in.
This is driven from the DevOps movement. I think .NET was behind in the DevOps movement,
yes.
Where it was very much, I've done my code, I've pushed it up to source safe, because that's what we used to use.
Yeah, I remember. Have you ever used ClearCase?
I have not. I don't believe I have.
Okay, it was like Kevlin has. He's sitting over there. It came on a DVD because it was too big to fit on a CD. So it was like a 900 megabyte source control system that was built for the enterprise.
For the enterprise.
Yes, it was glorious. Because it also came with ClearCase administrators. So if you wanted to make a branch, you would call somebody up and they would make a branch for you. That sort of stuff.
Yeah.
Lovely.
But yeah, this idea that the .NET world was very much in this idea of, well, I build my application, I send it off to somebody else builds it, and there's a package, and then somebody else goes and deploys it. I think what .NET Core has done is brought those developers into this world where you need to actually care about your production environment. You need to care what it runs on. You need to care how it's going to log its stuff out. You need to care about the outputs of this. And to the APM concern that you were talking about, where that idea of somebody caring about the request times, caring about the counters and stuff like that, they really didn't.
Yeah,
for me, now it is for them to care about.
For me, one of the big eye-openers was at some point we were struggling with production performance problems, right? And they came back with every release. And we didn't have good visibility on what our system was doing. It was built as a distributed system. It had a bunch of synchronous APIs, had a bunch of queuing in there, and we basically didn't know which code was causing it to be slow, which was a bad thing. And I started doing research, and it was in a time when application insights was still crap, but we convinced management to get us a New Relic license. And at that time, they were ahead of the game in a lot of the programming languages that they supported.
They were first to market with a lot of APM,
And we just dropped that on our... we included the packages and installed it on our servers, and that was basically all the effort that we did in configuring that product. And we learned so much about the system that we had been building for a long time in those first 2 weeks that we managed to halve the load on the database server by just performance tuning 2 stored procedures. Yeah. Because that's what the system told us, hey, you're calling this a lot and it might not be as fast as you need it to be. Whereas we always thought that it was another stored procedure that was actually really slow. That was the one that we believed to be slow in our mind. Whereas when we first were presented with the evidence, we learned that, okay, it's this one that we thought was really fast that's actually slow.
Yeah.
And we can easily performance tune that.
Yeah.
So it's all this limbo of sticking a wet finger in the air and figuring out where your problems are coming from. For me, this was a turning point in my career, because now visibility is the first thing that I do when I set up a new project, just to be able to know, when I drop this in production, I want to know what it's doing. I want to know where my problems are coming from.
So in Honeycomb, we refer to this as the MTT-WTF.
MTT, okay.
So it's the mean time to go in what the is happening on this particular system. And that's what observability gives you. That's what some of the APM tools used to do. That was the table stakes now. That's your auto stuff.
Right.
And I think what we're getting into now, and especially in the .NET world, is people understanding that actually, no, it's up to me to actually say what's interesting about my code. And now do some manual instrumentation. And I think that's where we're heading now with all of those tools that were the auto things, like let's just install the New Relic agent. Let's
you
just
could still instrument
app.
stuff manually, because we were using Unservice Bus, so I instrumented all of the handlers, because that's like a relevant scope of processing something, right? But even that didn't take too much effort to do. Instrumenting code is a lot easier than logging everything that you think might be interesting in the future to a logging platform, whereas you take the opposite approach, like let's instrument like a lot of things and then distill later what we need from this data. And that's stuff that we're really going to need if we move forward with these distributed systems. Because back when we started writing software, you would have a desktop application that would often contact the database directly. So you had like a UI in the database. That was the complexity of the system. So debugging and performance tuning, that was easy. Now you have an authentication service, and you have all these services that are calling each other, and there's synchronous calls going on, and there's queues in between, and so on. And often it's very nice to build on top of these cloud platforms that provide you all of this plumbing code and this stuff that we had to configure manually as a service, so that you can use it out of the box. But it makes the complexity of the entire system a lot larger, and it makes getting the observability right a lot harder.
So let me all of that stuff that you're talking about sounds incredibly complex. Do you think we're getting to a point now where everybody's over-engineering everything? Because everybody believes that I need a token server. I need 5 APIs.
The whole identity server discussion comes to mind.
Yeah. But do you think that's where we're heading?
I think we are as an industry prone to over-engineering. My credo is still like, as long as you can get away with it, just run a monolith. I know that's a very unpopular opinion in the industry, but I think
popular opinion in the room, but maybe unpopular outside.
I've always been a firm believer in solving problems when they present themselves, because you can pre-optimize for a certain problem that you think you're going to have in the future, but you're almost certainly going to have a different one, right? So I think like keep it as simple as possible, and that's why I really like that we're bringing back simpler services in .NET as well. But we cannot hide the fact that building on top of cloud, where you get a lot of your components as a service, and the fact that the potential for the number of users of the average application has grown tremendously. When we were first building software, you were writing line of business stuff inside an enterprise. These companies don't grow that fast.
Yeah.
And when they grow...
You know your users.
Yes.
You know where they sit. You know how many there are, because it's going to take 6 months to get through procurement for 100 more staff. So you knew.
and Moore's law plays to your advantage, because the company rarely grows as quickly as CPU power increases. So what you could do is like, okay, we have this thing that we built and it's struggling, but we have like 2 years of server evolution. Let's just buy a faster server, right? That's the thing we could do. With the web, that is no longer possible. You need to have scale-out scenarios. You're running on top of other people's infrastructure. Things are going to be more complex by default. Even if you're shipping a monolith in a container to Azure, there's like way more moving parts than you previously had. And it's not necessarily a bad thing, because it has commoditized a lot of things that we used to spend tons of time on, that like setting up a new project, as you earlier described, like bringing in all the packages. I think setting up something new, including deployment pipelines and monitoring and everything, that's like less than a day now.
Absolutely.
You can go from nothing to having source control, deployment pipelines, automated tests, everything like that is because of the efforts in the industry to commoditize all these things. And I think that's good. And the same thing is happening with the way we look at how code runs in production. That is also becoming easier. I'm excited to see what is going to happen in that space. I really like the fact that OpenTelemetry is catching traction, not just in the .NET ecosystem, but that we're seeing something that is going to standardize what we, the same thing that we talked about with iLogger, right? We have a standardized way of putting all the data into a system, and then we have a way of building all the monitoring dashboards that we want to have on top of that. And those two things can be decoupled from each other. That's something we've been lacking, and that is now coming, and it's going to revolutionize how we look at our code in production, I think.
So let's round it out with, are you excited about what .NET is going to be in the next decade once we have got rid of those decades worth of legacy applications?
Oh, absolutely. It's running faster than ever. It's moving faster than ever. It's hard for old guys like us to keep up with all the new stuff happening.
I'm not old, just to be clear.
Well, oldish. There's some gray in that beard. It's very exciting times to be in .NET. I think they're moving in the right direction for a world that is also moving really quickly. So, yeah, good stuff.
Well, thank you for your time, and I hope somebody got something out of this. I certainly did.
Happy to be here, and hope to see you at the next GoTo.
Indeed. Well, follow us on the Twitters.
Thanks for listening to this episode of the GoTo podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.